everyone, welcome back to Kidding Around. My name is Melanie Smith and I think it is totally terrific that you are here with me for another Test Tube Tuesday. Today we'll be talking about inertia. Before we do that though, if you like what you're seeing here and want to follow along with all of Kidding Around's videos, please subscribe to our YouTube channel and also below each video click the thumbs up. Thank you so much. Okay, so on to inertia. Have you heard that word before? Do you know what it means? Inertia is the resistance of an object to any change in its motion, including a change in direction. So that means that an object will stay still if it is still, or if it is moving, it will keep moving at the same speed and in a straight line. This still object, or this moving object, will continue doing what they're doing unless they are acted upon by an outside force. So let's break that down just a little bit. I have this pair of scissors here. I just placed them on the table, and my guess is that you expect them to stay there where they are. They rarely get up and walk around on their own, right? Right. So they're at rest, and they will stay there until they're acted upon by an outside force. So the cool thing about this is inertia explains objects that are still or at rest. It also explains objects that are in motion. So I have this glue stick here that I am going to roll to my scissors, which will be the outside force affecting the roll of the glue tube. So that glue tube continued to roll in a straight line and at the same speed until it was acted upon by an outside force. My guess is that you have felt inertia before. If you've ever been in a car that made a sharp stop, you felt your whole body go forward after the car stopped moving and then return to normal. That was inertia at work. We're also going to look here at another example of inertia. This baking dish is filled with water almost completely to the top. Even though the water is almost ready to come out, my guess is that you don't think that that water is going to come out on its own, right? And you are correct. It will not come out until it's acted upon by an outside force. And then it comes out. That, again, is inertia at work. So I'm going to clean this up and then I will be back with you with a few more inertia experiments. All right, the water is all cleaned up, so let's get back to our discussion about inertia. I have here what I call a jitterbean. It's an aluminum foil tube wrapped around a marble, and the marble inside can move freely so that when I toss this jitterbean, the whole thing moves in a way that you wouldn't expect. I'm going to show you how to make one, but first I want to show you what it does. Do you see the weird way that it rolls? I'm going to keep rolling it so you can keep watching it as I tell you what's going on here. So when the marble gets to the end of this jitterbean, the tube flips, which causes the marble to roll again, keeping the jitterbean in constant motion. The marble continues to roll around in the tube until a force stops it. This is that property of inertia that we were talking about, in which an object tends to resist any change in motion. So these are very fun to play with, and they're fun to watch people watch too, because they don't expect them to move the way they do. So let me show you how to make one. The materials that you will need for this project are a sheet of aluminum foil, a large glue stick, a pair of scissors, a ruler, a pencil, a marble, and a small box with a lid. A shoebox works great for this. Okay, so then to get started, what we are going to do is measure out a 5" by 3" piece of aluminum foil. So there's my 5 inches, there's my 3 inches. I'll go up here and mark my line, and then I'll come down here and mark this line. So once you have that measured and marked, you can go ahead and cut the piece of foil out. Again, this doesn't need to be perfect, as none of our projects do, just about 5" by 3". And aluminum foil is sometimes hard to cut because it tears, so make sure to go slowly and gently. Once you have your piece of foil, we're going to go ahead and wrap that around our glue tube. The thing that I should mention here is that your glue tube should be a larger diameter than your marble. I'm going to put that marble in the scissor hole so that its inertia doesn't take it off the table. All right, the reason that you want this diameter of the glue stick to be larger than the marble is because the marble should be floating around freely in the tube once it's made. So, okay, now you've wrapped your foil around your glue stick, and then you're going to make the end. So you're going to slide the foil down to the end of the glue stick and then fold in all of the edges. If you still have a little bit of a hole there, as I do, go ahead and scoot your foil just a little bit further down the glue stick and then refold it so that there are no holes there at the end of your tube. Then you're going to gently pull the glue tube out of your tube, and you're going to put your marble in. Once you have your marble in, set it on a table and then try to gently fold in the other edge. This gets a little hard because you're not using the glue stick, but if you just kind of fold in like that, once you get to about this point, then you just kind of squeeze it shut. We don't want any holes in this end either, so make sure that it is completely closed. All right, once you have that done, you'll take your box and you'll put your tube in it, and then you're going to shake this box for 45 to 60 seconds. I'm going to speed up the video, but I want you to see how I'm shaking my box. I'm going to go forward and backward, left and right, up and down, so you should do that too for 45 to 60 seconds. All right, here we go. Okay, once you've shaken it for 45 to 60 seconds, your moment of truth awaits you. Reach in your box and see what you find. I find a jitter tube, and you will too. In true scientific fashion, though, we need to make sure that it works, right? Here we go. Cool, let's try one more time. Awesome. So you can amaze your family and friends with this bean that moves in a way that most people will not expect it to. Also, if you accidentally squish it and the foil kind of folds, don't worry about it. Just put it back in your box and do your shaking of 45 to 60 seconds, and it'll come out just like new. All right, let's continue on with our inertia fun. I have here 2 eggs. One is raw and one is hard-boiled. I'm going to spin them, and in mid-spin, I'm going to stop them. The behavior of the 2 eggs will be different. I'm curious if you have an idea of what is going to happen. Should we find out? All right, here's the first one. Did you see that? We'll do it one more time. Okay, so that's the behavior of the first egg. Now let's do the other one. This one doesn't spin quite as well, so it may take a little bit to get it going. Did you see that? We'll try it one more time. Did you see? All right, so they acted a little differently, right? This one spun pretty freely, and when I stopped it, it stopped. This one, when I spun it, it was harder to get going. And then when I stopped it, it continued on around. So, the first egg, if you think that this is the raw egg, raise your hand. If you think the second egg that I spun is the raw egg, raise your hand. If you say it's this one, you are correct. The second egg that I spun was the raw egg. And if you noticed, after I spun it and stopped it, it kind of continued on. It stopped for a brief bit, and then it continued on. And that is because inside this egg is the yolk and the white that's moving all around, not wanting to stop moving which way it's moving because of its inertia. On this hard-boiled egg, the yolk and the white have fused together and to the shell, so this is a solid piece, so it moves more as one. Pretty cool, huh? Okay, we have one more inertia experiment to do in our time together today. So this one will require a drinking glass, a piece of cardstock that is big enough to cover the opening of your drinking glass, a cardboard tube, this one had paper towels on it, and then something circular and something that is big enough to sit on the top of this cardboard tube without going through, and is also small enough to go inside the glass. All right, there we go. I'm going to set up our experiment, and then I'm going to ask you a couple questions. Knowing what you know about inertia and the fact that once something is going in one direction, it does not want to change direction, what do you think is going to happen to this apple if I pull out this cardstock? Do you have an idea? All right, let's see what happens. All right, 1, 2, 3. look at that. Wasn't that cool? The apple, with its downward inertia, fell right into the glass. It didn't go along with the cardstock or the paper towel tube. All right, I have one more thing that I would like to try with this experiment. Are you ready to see if we can make an egg go into the glass? This feels like it's big time stakes, doesn't it? All right, I've got my raw egg. There we go, I'm putting it on the top. Let's see if that egg will fall into the glass. Man, I hope it does. All right, 1, 2, 3. Look at that, it did. Perfect. It will work that way every single time, as long as when you're pulling out this cardstock, you pull it straight out. The cardboard will fall this way, and whatever is on top of that tube will go right down into that glass. Be sure to check with your parents before you try this experiment with a raw egg, okay? All right, well, I hope you have had a fun time with me today learning all about inertia. It's been a blast. If you like seeing these videos, please make sure to follow our YouTube channel, and also, again, remember to click the like button on all of our videos. I've had a great time with you today. If you would like to show me what you're doing and show me your inertia experiments, please feel free to put them on our Facebook site. I can't wait to see them. All right, thanks so much for joining me for this Test Tube Tuesday. I will see you next time.